Hi, I'm Kireeti Magalanadu. I am studying second year BTech in JNTU College of Engineering, Anantapur. I made this video due to the assignment given by our professor, Mr. Somasena Reddy, related to data structures. My topic is polynomial representation. In this video, I made clear explanation about polynomial representation using linked list. I also made brief introduction about linked list. Please watch the video. Polynomial representation. It is the one of the important applications of linked list. Linked lists are the important concepts of data structures. So before understanding polynomial representation, it is important to understand what linked lists are, how are the basic operations are performed, and some other important points of linked lists. So linked lists. Like arrays, linked lists are also the linear data structures, but there is a small difference. In array, the adjacent blocks have the adjacent memory locations, but in linked list, the adjacent nodes do not have the adjacent memory locations. They are very random, but they are connected through some pointers. In linked list, each node have data and address. I mean, it has two parts. One stores the data and other stores the address of the next node. Data part contains an integer or a float or a double or a character. Sometimes it can even contain strings. Representation of singly linked list. Singly linked lists are represented in the method that I previously discussed. It has have nodes which contains at least two parts. First part is a data item. Data item cannot be a single one. Sometimes there will be two data items or multiple data items. Whatever, how many the data items may be, they can store integers, strings, or any other data type based on what we define them. Okay, and the pointer always refers to the address of the next node. The head of the, I mean, like the first node of this linked list is referenced by a pointer called first. I'm going to explain every topic in point of view of C programming. So, in C programming, we use structures, pointers, and some concept of dynamic memory allocation to work on linked list. So, if you watch at the bottom screen, you can see there is struct node open brace into data struct node star next closed brace, which means struct is a keyword used to construct a structure. Node is the name of the structure. So as I already said, there is a two parts, right? So integer part is the data, and the struct node is we are making it a self-referential structure, so it refers to the address of next node. So star next is the pointer which will refer to the address of next node. I hope you understand, right? We will see the visualization so you can better understand it. See the data part. Data part is the thing that I use it to represent into data. See, we go back and we'll see again. A struct node into data. Into data is the part that is used to refer the data part, and address part is the star next. It is a pointer that will refer to the address of next node. I hope you understand. Next, before going to further topic, we have to understand why linked lists are used. We have arrays, right? They are also linear data structures, but how these linked lists are different. In array, the number of elements that can be inserted or the size of array is fixed. In C programming, we define array, I mean the size of array before working on it. So the number of elements that can be inserted into an array is fixed, but in linked list it is dynamic, it's not fixed. We can insert how many elements we want, or we can delete how many elements possible. It means there is no limitation. It depends on the functionality of our computer or the RAM size. Insertion of a new element or deletion of an existing element in an array elements is also expensive, which means if we have to insert an element in middle into an array, it is very difficult because we have to shift every element to the next column so that we can make some space to insert this new element, but in linked list it is not. We can see it clearly through visualization. Let us compare array and linked list. Okay, so first of all, let us assume we have an integer array. So this is the integer array. We have 8 blocks. Okay, 8 blocks. We let us say the size of this array is 8. It is an integer array. So let the first block's address will be 1024. So what will be the next block address? So integer size is 2 bytes, right? So it will be 1026. Similarly, the next will be 1028 and next will be 1030, and simultaneously it increases like this and it reaches 1038. This is how memory is allocated in arrays. But in linked list, memory is not allocated in this way, as I previously explained. Let us see how memory allocations in linked lists are done. In linked list, memory allocation is not contiguously allocated. Here pointer stores the address of first node, see 1024. Let us consider the address to be 1024. Then the next node will be, see, it's not continuous. It's not 1026. It's like some 10299 or something else. It will be giving some random addresses. When another node is inserted, it is like 3024. It is also not continuous. Like this, 12026. Like this, these addresses are not continuous and they're just connected through the pointers that are in the address part of the particular structure. Now, let us take an example. In an array, we are maintaining a sorted list of IDs in a office. So the IDs are like 1000, 1010, 1050, 2000, and 2040. They are inserted into an array. Now we have to insert a new ID. There is a new employee whose ID is 1005. Now to maintain the sorted order, we have to move all the elements greater than 1005 so that it will have some room to be inserted. So 2040 is shifted to the next one, 2000 is shifted to the next one, 1050 is shifted to the next one, then 1010 is shifted to the next one, and finally 1005 will have some room to insert it into the particular array. Then 1005 will be inserted. Now consider the same example in linked list and how this operation is performed. Now the same case. Now we are doing through linked list. Okay, what we will do, we will create a new node so that we don't move any data from one node to another node. That all the nodes that already exist will be remaining same. A new node is created and the node 100 and 1010 are the preceder and successor of this new node. So what we have to do is 1000 will refer to the address of 1005. Then 1005 will now will store the address of 1010 in such a way without transferring any data from one node to another node. By just creating a node is inserted into a linked list. Friend, from arrays, let us go through some deep and we will understand what are the basic operations on linked list. There are some basic operations on linked list. There are insertion, deletion, search and display are traversing methods. Now let us go through insertion. To insert a node into the linked list, we need to do the following steps. Find the node before or after which the node to be inserted. Change the pointer references appropriately. It means like we have to find the position where we have to insert the node. Like in the previous example, we inserted 1005 between 100 and 1010. Like that, we have to find the position where it has to be inserted, and we will do the necessary uh, programming steps so that the node will be inserted. Let us see the front insertion method of inserting a node. So follow through me. Sorry. So cursor. it is a function in C programming. So void f insert, which means front insertion, struct list. Struct list is used to create a pointer, like we used like a int star x means creating an integer pointer. Now we are creating a node pointer, struct list star new, which creates a new node. New node struct list star malloc size of struct list, which we are using dynamic memory allocation to create a new node. Now we are scanning a new data value to be stored into the list. New next is equals to null. We are I'm making sure that no address this like garbage addresses are not stored in the garbage addresses are not stored in the null point, address of the new node. So here comes the execution. If first is equals to null, which means if the linked list is empty, new node will become the first node. You understand, right? New node will become the first node. Else, new node address will reference to the first node, and first node becomes the new node becomes the first node. For clear explanation, we will see how it happens in visually. Consider the following list. Okay, we are doing front insertion. In front insertion, a new node is created. Then the address pointer in the new node will store the address of the first node. Then first pointer will store the address of new node. From now, new node becomes the first node. This is how front insertion done. Let us see another example. Similarly, now we are inserting another new node 899. Since the list is not empty, now the new node will store the address of first node, and then first new node becomes the first node. This is how front insertion is done. Now rear insertion. First few steps of till the if step creation of new linked list, everything is similar, but in the else part, temp is equals to first. This pointer is used to traverse through the linked list, so we can reach the end of the linked list. See, while temp next is not equals to null, when we will get the address pointer as null at the ending of the linked list. So we are using this while loop to traverse through the end of linked list. Once the temp reaches the end of the linked list, now the temp address will store the address of new node such that the linked list is expanded and the rear insertion is done. We will see it visually. See, in rear insertion, a new node is created and temp pointer used to traverse to the end of the linked list. When this happens, finally, the address pointer in the temp node will store the address of new node. Thus, rear insertion is done and the linked list is expanded. Similarly, another example we will consider new node, which contains 3000. Temp traversed through the end of the linked list, and now temp stores the address of new node. Thus, linked list is expanded. This is how rear insertion is done. Deletion. To delete a node from the linked list, we need to do the following steps. Find the previous node of the node to be deleted, change the next of the previous node, free the memory for the node to be deleted. To understand these following statements, let us see the programming and the visualization. This is the program of front deletion, which means we are deleting the first element of the list. Struct list pointer. We are using dynamic memory allocation to so that the pointer will have the some memory. In if statement, if the list is already empty, it will print list is already empty. If not, then temp the new pointer will start referring the first node, and the first node will now become the from then first node will start referring to second node, and we will free the temp. You didn't understand it, right? What will happen is this first node and temp node are both are same, and we will make that temp and first both start referencing to the same node. Then first will now start referencing to the second node, and the temp will be referencing the previous node only. Now we will use the free method so that temp is erased. Now the linked list is underwent to the front deletion. So one element at the starting of the linked list is deleted, and now the first second node became the first node. Similarly, another example, now 900 node is being deleted. See, the first and temp are both are referencing to the same node. Now first node start referencing to the second node, and using free method, first node is erased. This is how friend deletion is done in linked list. Now the rare deletion. The following program, everything is same until the if statement. In else statement, we use the if statement. It is somewhat complicated than the front insertion. Okay, why it is complicated means if there is only one node, we have to use this if statement. If first next is equals to null means it will have only one node. We have to clear that node. So we store this data. Temp is equals to. We'll store the first in temp. Now temp and first both refers to the same node, and now we will ensure that first is equals to null. So now first will not refer to anything, and we will free the data that is being referenced through temporary pointer, and we will return from this method. Now if this if statement is not true, the next statements will be executed. Now this temp, whatever this temp pointer will be used to traversing through the end of the linked list, like we do in the rare insertion. And this x will be used to traversing through the previous node of the end node. We will understand it. See in visually here, see the after this execution, the temp will be referring to the final node, and the x will be referring to the previous node of the final node. Now what will happen, the x will stop referring to the next node, temp node, such that now temp is not being referenced by any node, and then we use the free method to delete temp. This is how rare deletion is done. Similarly, next example, we will delete 2080 in the same method. First x will stop referring to the temp, and then temp is removed using free method. This is how the basic operations performed: deletion and insertion. Search and display are the traversing method. We will see how the search is implemented: void display struct list. And this is just like traversing, like we traverse it through the end of the linked list, right? We use the same method before changing to the next node. The data in the node is printed. This is what represented in this display. Now we will see execution of these programs using C programming in VS Code. Now we are now we are in VS Code. It is an integrated development environment. Let us quickly go through this program. The header file section, we included two libraries: standard input and output console, and standard library. And struct we use it to create nodes, and a global pointer first is declared. And for we declared five methods: front insertion, rare insertion, front deletion, rare deletion, display method, and the main method. In the main method, I used for loop and switch case to select the options, and the methods that I already explained in the PPT. So let's execute this program. So now I'm entering the choice. Let us create a node first. One. Now we will do the friend insertion. Two. Now we will do the rare insertion. So we have done now front insertion and range insertion, and these values that are being displayed in this output is using display method. Okay, now we will do front deletion. See, the 3 is deleted. Similarly, again we will do front deletion. Now we will do rear deletion. So this is how the programs are performed. Now we will go through the further concept. Applications of linked list in data structures. Linked lists are used to implement stacks and queues. It is used for various representations of trees and graphs. These stacks, queues, trees, and graphs are the important advanced data structures. And also it is used in dynamic memory allocation, linked lists of free blocks. It is used for representing sparse matrices. And before going to real life application, one of the important application is my current topic, polynomial representation. Now we will go through quickly applications in real worlds and advantages and disadvantages. We'll go through the main topic, applications of linked list in real world. We the music player, song queues, that are the one of the important application of linked list, like the playlists, music playlists, the web browsers, previous and next pages, and image viewer in our gallery, and so on. There are many examples, and we'll quickly go through advantages of linked lists. Insertion and deletion in linked lists are very efficient. Linked lists can be expanded in constant time for implementation of stacks and queues and for representation of trees and graphs. They are used, and it is very important. Linked lists are used for dynamic memory allocation, which means effective memory utilization, hence no memory wastage. Disadvantages of linked list. Use of pointer is more in linked list, hence complex and requires more memory than the normal usage, which means arrays. Searching an element is costly and requires O and time complexity. Yeah, it takes more time. Searching means, if for example we are searching for the rare end element in linked list, it is 100 in length. So we have to traverse through every node and end reach the end, so that we have, so that we can search the element that is required. So searching is very costly and traversing is more consuming, and reverse traversing is not possible in single linked list. So as we have seen, single linked list only represents forward. They are not meant to come backward. So it is not that easy to, actually it is impossible to reverse traversing in single linked list, but it is possible in doubly linked list. Random access is not possible due to they are linear structures, right? So random access is not possible. These are the disadvantages of linked list. Now let us go to the main topic, polynomial representation. Polynomial. What is a polynomial? A polynomial px is the expression in the variable x which in the form of ax power n plus bx power n minus 1 and so on, where a, b, c, k fall in the category of real numbers and n is non-negative integer, which is called the degree of polynomial. An essential characteristic of the polynomial is that each term in polynomial expression consists two parts. One is coefficient, other is exponent. Consider the following example. 10x square plus 26x. Here 10 and 26 are coefficients and 2 1 is its exponential value. Points to keep in mind while working with polynomials. The sign of each coefficient and exponent is stored within the coefficient and the exponent itself. We have to store the sign in the no I mean in the part itself. We cannot use some other data part so that we can store the sign value of coefficient exponent. So we have to use these signed in forms so that we can store the exact values. Additional terms having equal exponent is possible one. So we cannot use the duplicates having equal exponent. The storage allocation for each term in the polynomial must be done in ascending or descending order of their exponent. We have to do the sorted insertion, which means we either have to represent this polynomial from the lowest degree or the largest exponent. Let us see the program and the visualization so that we have the clear explanation of this representation of polynomials. Insertion and creation of a polynomial. So two parameters are passed, element, exponent and coefficient. So struct poly is the node that is used to create this polynomial nodes. Struct poly. We are using three pointers to refer this to make this work. Three are dynamically memory allocated. In new pointer, we are making sure that address is address pointer is null and the exponent coefficient are given assign some values through the included parameters. If the polynomial is not created using this if statement, the new polynomial is created, that is new node is created. If the polynomial is already created, and if the exponent of the first node in the polynomial and the exponent of the new node are equal, then the coefficients are added and the value is stored in the coefficient of the first node. If it is not true, then we have to check if the exponent is greater than the first node or the smaller than. Exponent is the if the exponent of the new node is greater, then it has to be inserted before the first node, that is front insertion is done. If not, then we will traverse through it. While traversing, we have to make sure that the next node should have the if the next node after the first node, if the exponent of the next node after the first node is greater than the new node, then it is further traverse. If it is not true, the middle insertion is done. I hope I know you didn't understand through my words, so I will show it visually. See, now the first node is created. Let us consider this example: 4x power 4 plus 3x plus cube plus 2x square plus 1x plus 7. Now I'm not giving the creating the polynomial in order. So now I'm creating the first step is I'm giving the coefficient and exponent is 3. So the new node is created. And then now I'm giving the values, coefficient is 4 and exponent is 4. What happens? It searches. Now we have seen that the first node is the first node's exponent is smaller than the new node's exponent, so the front insertion is done. The next step, now what I am doing is I'm inserting another values. The coefficient is 1, exponent is 1. It is smaller than the first node and it is smaller than the second node, so it is further traversed and inserted at the end. Rate insertion is done. Now what we will do, now we will insert another value. The coefficient is 2, exponent is 2. What happens? The coefficient, the exponent 2 is smaller than the first node's exponent, second node's exponent, but it is bigger than the last node's exponent. So it is inserted in between the this node and this node. That is, the node which has the exponent 2 is inserted between the node that has exponent 3 and exponent 1. And the final one, the constant. Now we gave the values 7 and 0 such that the constant value is inserted, hence the linked list of the polynomial is formed. Now the display method plays very important role in representing polynomials. Let us see quickly and understand how important the display method is. The struct poly, the node is created and the pointer is referenced and the pointer has given the dynamic memory. And now this temp, this pointer is used through traversing. So temp is equals to first. So now from now temp starts referring to the first node. What happens? We are printing the first node elements as it is. Temp until and unless if the coefficient of the first node is not equals to 0, the value is printed. In the if statement, we are just making sure that the first node coefficient is not 0. If it is 0, then the value is not printed. And then it is now start referencing. I mean, if it is now start traversing to the next node. Well, what are the criteria we are checking through this traversing is we are if the coefficient value is positive, then the plus symbol is not printed. So we are writing a program that if the coefficient is greater than 0, then in the print statement we are including plus. If the coefficient is less than 0, we don't have to include anything because the minus symbol is already included. And here we can observe this temp co is equals to 0. It's not there anything because if the coefficient is 0, then we don't have to insert anything, right? While performing some addition, we might encounter some coefficient might be 0. Then in general what we do, we don't use that in general what we do, we don't use that coefficient, right? We don't use that coefficient. I mean, we don't write that exponent form in representation. So here also I'm eliminating it. So in this way display method is used. We will see it clearly while executing the program. Okay, now the another example, 1x power 4 2x cube plus 3x square plus 4x plus 5 is also represented using linked lists. Now I will just show you how the addition and multiplication program is written. It is not the important topic now, but I'm just showing you, and I will show the how the program is executed line by line in the in by using Turbo C so that we can trace it. So this is how the addition program is done. You can take screenshots and you can just see it, and I'll show you the total program using VS Code, and I'll execute the program in Turbo C. This is addition. See, this is the linked list that is formed after the addition of the following linked list: 1x power 4 2x cube plus 3x square plus 4x plus 5, and 4x power 4 plus 3x cube plus 2x square plus 1x plus 7. And this is the multiplication program. The multiplication is very simple when compared to the addition. And this is the polynomial that is formed after multiplying these two equation: 1x power 4 plus 2x cube plus 3x square plus 4x plus 5x 4x plus 5 and 4x power 4 plus 3x cube plus 2x square plus 1x plus 7. And the product of the following equations is 4x power 8 plus 11x power 7, 20x power 6 plus 30x power 5 plus 47x power 4 plus 40x cube plus 35x square plus 33x plus 35. This is the total polynomial program that I have written. You can use the references to perform this multiplication and addition. My topic is polynomial representation, so I'm not explaining this multiplication and addition, but I am just showing how this program works. For your better understanding, I'll show this representation method using Turbo C, because in Turbo C we can trace the program line to line and we can watch what happens to the variables in watch column. I will put these two programs in my description so that if anybody wants to copy and use it, you can use. The program that I already showed in the VS Code is now being represented in Turbo C. Why I am using Turbo C is that we can see line to line execution and we can watch what happens to the variables. Now I'm going to show you how this display method and insertion method works in this polynomial representation so that we can end our video. So I'm now using the watch function to insert the variables that I need. Sorry, this first data is not existing, so I have to delete it. I was just thinking about linked list. C4 for coefficient, EX for exponent. Insert temp EX, insert temp CO, insert rev CO, insert rev EX. Okay, we have these necessary variables that we have to watch. So now we are going to watch the line to line execution. The now execution starts at main, entering choices. So enter the values and select the negative. So to break this loop, we have to use the negative exponents. Okay. What we will do, we will 1 F7. Now the insert function. Okay. I actually forgot to insert. We will insert now. So till now, no node exists. So first node is created. Again, scanning another value. What we will do, exponent 2, quotient also 2. Now it is comparing if the exponent size is equal. No, it's not equal. If the exponent of the first node is less than the exponent of new node, yes, it is, then the loop is possible. So it terminates from the function and again it asks the exponent. 3, F7, again 3. See, we can see the new node. If it is checking if the first node is bigger than the, I mean, exponent of the small first node is smaller than the new node. Yes, it is true. Again, it is doing the same thing. Now, what we will do, we will give the exponent. We will enter the constant term 7. Now, new node exponent is 0, constant is 7. First node is not equals to null. First node exponent is not equals to new node exponent, and first node exponent is not less than new node exponent. So the else loop is first time executed. Now traversing starts. Previous equals to temp. What happens is it compares the values of the node and it will insert when it is suitable. So here the rare insertion is done. So the new node inserted is at final. Okay. And now the final last one we will insert exponent 4. Coefficient is also 4. The same execution is done. Enter the exponent. Now we have to terminate the loop. So I'm entering negative exponent. So then now the loop is terminated and the display method now start traversing. Okay. The first loop is printed. It's traversing. You follow the blue colored line. You can see here in the watch column how the values are changing and what is the value that is being printed. Okay. Now the loop is terminated. We will see what is the output we got. See, we ended 4x power 4, 3x cube plus 2x square plus 1x power 1 and plus 7. This is how the polynomial is represented. Now we will stop this and we will use the control F9 so that we will have the following. Uh, we will do the next thing. Okay, I'll show how the multiplication and the addition is performed using this program. Mm, exponent is 0. Mm, now the two exponents are done. So we already had some exponent. I mean, we already had this expression. So what happened is the values that I again entered, it doesn't accept duplicates. So it added to the previous coefficients. Now what happens? Now we will perform the addition. See, it is the sum. Now we will perform the multiplication. This is the multiplicative value of the following thing. So this is how the polynomial representation is done. I know I didn't explain the addition and multiplication properly. Uh, Maybe next time, but my assignment only is up to polynomial representation. So I'm really sorry. So thanks everybody for watching this video. Whoever watched this video, sincerely thanks from my side.